Here to talk about the bicycle-powered generating station, and we're using the method of using a car alternator. And I'll talk a little bit about the trials and tribulations that we went into getting this to work. Most of the parts we've got donated. The alternator was from Gundy's Auto Recycling, and then we had that tested fine, but we just couldn't seem to get it to work on the bicycle. We even went as far as hooking it up to a lathe up at Western Washington University, and trying applying sense voltage to the sense terminal, and just couldn't get anything going with it. Did a little research on that, and it turns out these alternators don't really turn on till over 1,000 RPM. Now that's 1,000 RPM at the alternator pulley. Now with the mechanical advantage in the car, that can be around 700 RPM at your idle speed. So we figured that out, and we were kind of fighting that. So what we did is we decided, and I'm going to move the camera here in a minute, but we moved to hacking into the alternator directly to the brushes going to the field terminals there in the center on the rotor. And what we did is we got that hooked up as a circuit, so we can just energize the field circuit when we want, generate our power, and shut it off when we're done. And it's amazing the difference it takes to pedal this thing when you're energizing that field coil. So we've got it set up with a switch to do that. We've got a separate battery. We went with this route because we figured when we're generating, we don't want to be using all our energy to also energize the field coil. So we got two smaller 7 amp hour batteries. These are ones they use in emergency exit signs, and kind of an interesting fact, I think the National Electric Code or Fire Safety Code requires those be replaced every couple years, even though they're still good. So a lot of these sealed lead acid batteries are going in the dump. So we've got a couple of those that were bound for the recycle pile or whatever, and we're using those. And we're also going to, I'll show you in a second here, we're going to be using a solar panel to be charging our spare one. So when we notice after we've been generating about an hour that we need to switch out batteries, we'll have a spare that's been charged up by our solar cell. So I'm going to stop the camera, and then we'll give you a little tour of the bike. Okay, so now we're looking at the bike here. You see it's an old exercise bicycle that we've converted, and here's our dashboard. If you want to see there, we've got our DC volts. Right now we're sitting at about 13, and this is our switch right here we'd use to energize the field coil. Down here, as you can see in the front of the bike, we've got the two batteries. A smaller one that's going through the switch and activating right down here at the hack we did, where we're going right to the field coil. Now we had this originally going with a belt, but as you can see, the surface here is smooth, and the bike, is a little rickety, and any movement there, the belt would slide off, so it got very frustrating. So we went with a direct drive. I wanted to get a hard rubber pulley from some industrial supply house. We were unable to do that, so what we did is we used Gorilla Tape, or that self-fusing tape, to build up a surface on the pulley, and you can see it drives it pretty good. Now this particular alternator, that was another thing I never realized. The alternator had to be spinning in a certain direction, so we had to be aware of that. So I'll just show you there. There's our small battery, our alternator with our mounts. I got a little turnbuckle here to keep it smooth or rigid. We're using a small inverter that was donated, and then we got a outlet strip there. That trouble light's just plugged in there for a load for our test, but in the end what we're going to be doing is powering just small cell phone chargers and the like. So let me take you over to the charging station. We've got a spare one of those sealed lead acid batteries from the emergency sign that we're using for that. So we could, in theory, just go hook that solar cell up and charge it right over there, but Nathan doesn't know where this will exactly be used, so it's good to have it portable. We just got some alligator clips on there. So we're going to turn on the inverter, turn on our load. That noise you hear is the inverter. And I'm sitting at about, looks about 12.5 volts. I'm going to get started pedaling, and you'll notice my feet will change speed here when I kick in that field coil. I get that magnetic resistance going there. I got to work a little harder, but I'm able to keep it up actually about 13 volts at that point. And if you get tired, you can shut it off, take a little breather, and start up again. It's nice to have that flywheel to keep a little momentum going, and we haven't calculated what our mechanical advantage is, but you're going to need about at least a 10 to 1. Okay, I thought I'd give a little bit of a wrap-up on this project with Nathan and his team. As we decided on this making the generator, it was a lot more economical, certainly a lot more economical, to go with the car alternator over the permanent magnet DC motor. Buy one of those new, you were looking at about $300, and the alternator, once we explained to local auto recyclers what we were doing, we got them for free, and I'm sure you could pick them up even if you didn't have a connection like that for pretty cheap. So that's what we did, and certainly the bypassing of the internal regulator going directly to the brushes helped out. Gave us a lot more control, just flicking it on and off. Definitely, if anybody does this, I recommend they do the same. And if we had a little more time, we thought we could have added like a couple power resistors in series with that, so we could maybe vary the amount of, just roughly vary the amount of current we had going to the field coil on that. So a thought for the future. And then on our particular design, not having a groove for the belt on the flywheel, we decided, as we said earlier, to go with the pressure roller, but we couldn't find one. And I think so if we had more time to spend with that, and maybe on the choice of the alternator, choosing a alternator that had a slightly longer shaft, that would give you a little bit more leeway in finding an aftermarket hard rubber pulley from a local industrial supply house. And then the mount, we were just using some steel. We started out with aluminum brackets. Nathan and the team worked with aluminum, that's what they had, and then we had some steel brackets which were a little bit more sturdy. But if we had more time to create, maybe get somebody with a little welding experience to create us a little cradle, if you will, to mount the alternator in, and then have some little slots in there where we'd be able to, you know, snug it up as needed, tighten it down, and then kind of for a service mode to loosen it up, give us a little bit of adjustment there. And like I said, if they need to get going this week off to Pullman to show the project off there at Wazoo, but if we had more time, we'd do that. But it was a lot of fun, and I wish them well, and look forward to working on any more projects.